Hello, in this video I'm going to say a little bit about Cecilia Payne-Gaposchkin, the British-American astronomer astrophysicist from the 20th century, probably the most famous female astronomer of all time. And there are other female astronomers, but she's the one, certainly for me, who springs to mind first. And she was a real pioneer in the field of astronomy, both for women and just astronomy in general. So she was quite the groundbreaker. Probably most famous for being the first person to determine actually what stars are made of, as in stars are primarily made of hydrogen and helium, which, okay, is common knowledge nowadays, but you go back 100 years and it really wasn't. The prevailing view back then was that the sun had a similar composition in terms of its distribution of elements to the Earth. You know, everything in the solar system was formed out of the same stuff. People assumed that, well, the sun would have a similar composition to the Earth. It was just hotter. So that's what people were thinking. And Cecilia Payne changed that thinking, although not easily, which I'll get onto later on. So a little bit of background to her life then. She was born in England to a relatively affluent family. Her father was a lawyer. He was a noted historian. Her mother was from a distinguished Prussian family. So Prussia, a country that no longer exists, but was sort of roughly where Poland is nowadays, between Germany and Russia anyway. And yeah, it was quite a distinguished family on her mother's side. So they were well off enough that she could be privately educated. And then she got a scholarship to Newnham College at University of Cambridge. So this is one of the women's colleges at the University of Cambridge. Now, they weren't studying on an equal footing to the men because University of Cambridge, like most, if not all other universities at the time, weren't awarding degrees to women. The University of Cambridge didn't start awarding degrees to women until after the Second World War. I think it was 1948. But still, she was studying there. And she was studying physics and chemistry primarily. She made the switch to astronomy and astrophysics as her focus after she attended a lecture by Arthur Eddington. Now, Eddington had been out to Africa to test Einstein's theory of general relativity. There was a solar eclipse, a total solar eclipse in Africa in 1919. And this was an opportunity to actually get observational evidence to back up Einstein's theory, which Eddington managed to do. He went down to the island of Principe, which is sort of off the west coast of Africa, and he gathered this evidence from the eclipse, verified part of Einstein's theory, came back to England, started giving lectures. Cecilia Payne, as she was then, I mean, she got the Gaposchkin after she got married. Cecilia Payne, she went along to one of these lectures and it completely changed her thinking about science and her aspirations to do with science. So that was what set her on that path. Trouble is, once she finished her studying at University of Cambridge, she realised the situation in the UK, as it was for women who were educated at the time, their career options really shrunk down to being a teacher. And that isn't what she wanted. She wanted to do research and to continue studying science, not to be a teacher. And she met some chap who was over from the US who worked at Harvard University. And she managed to persuade him, based on her considerable talents as a scientist, to get her a place, help her get a place in Harvard University in order to do further studies, where she went to do her PhD. So she moved out to the US, studied at Harvard, and the PhD that she did when she was at Harvard was actually the first PhD in astronomy that was ever issued at Harvard University. So again, groundbreaking stuff. After she completed her PhD, she stayed at Harvard and made her major breakthrough, which was when she was studying stellar spectra. So as I've said in a lot of previous videos, one of the big problems that needed to be solved in the early 20th century when it came to astronomy and astrophysics was distance scales. So people were looking at luminous stars, they were looking at stellar spectra, they were looking at variable stars, they were trying to get some way of determining how far these different stars were away from Earth. If you could then do that, they were constructing the Hertzsprung-Russell diagram, trying to then what would later feed into determining life cycle of stars. So this is what Payne was looking at. She was looking at luminous stars. She was looking at variable stars. She was looking at stellar spectra. Her breakthrough, though, was she managed to combine her observations. Well, in fact, it was a lot of people's observations that were recorded in these stellar spectra. But her analysis of these observations, her analysis of these stellar spectra, she managed to then combine with theories to do with ionization state based on temperature. So other people's theories, she then managed to connect with observations and bring these two things together. And she then determined from this that actually, no, these absorption lines that we're seeing on these stellar spectra are telling us that stars are overwhelmingly made of hydrogen and then helium. So those are the main two elements, but obviously hydrogen being the most dominant. So as I say, this was completely groundbreaking and not a lot of people accepted it at the time. It was so different from the prevailing view. And one person famously, Russell of Hertzsprung-Russell diagram fame, he actually dissuaded Payne from, really committing to that result, to that finding that stars are mainly made of hydrogen. And she started to some doubt started actually creeping into her thesis as she started questioning her own results. Now, a few years later, Russell actually acknowledged that Payne was correct. He gave her credit for, leading him essentially to some of the work that he did later on. But this is something of a sore point amongst many historians of science, saying that Russell ended up getting more credit for his subsequent discoveries than Payne did for the original ones. So I can't really comment too much on that myself because I haven't actually looked into the details of exactly what Russell did. But it wouldn't be that much of a surprise considering the inequalities that women in particular were facing back in the day as scientists. So it would fit in with that narrative. Anyways, she had made that great breakthrough. She remained at Harvard for the rest of her career. But again, she wasn't allowed to take a professor role because women weren't allowed roles as professors. But she still managed to get to do some research, maybe not the research that she would have liked, maybe not the research that she would have been able to conduct and deserved to be able to conduct, but she managed to do research nonetheless. She was surveying more of these high luminosity stars, these variable stars, and a lot of this she did in collaboration with her husband, Sergei. So in the early 1930s, she did a tour of Europe, going around various universities and observatories. And she went to Russia. So this is communist Russia in the 1930s. She also went to Nazi Germany. This is the early stages of Nazi Germany, obviously before they got onto the really bad stuff, but it was still hardly a pleasant place to be. So two really, really dodgy places to go and visit, risky places to go and visit, where scientists were under considerable threat, along with large proportions of the rest of the population. This is where she met Sergei Gaposchkin, a scientist who, Russian, he had managed to get out of communist Russia and the threats that he was facing there, but now he was trapped in Nazi Germany with the threats he was facing there. So out the frying pan into the fire for Sergei. Cecilia Payne, she managed to help Gaposchkin out of Germany over to America and into research with her at Harvard University. So that was quite something to do, to stick her neck on the line in that way and get who then became her husband a visa to get into the US. So yeah, remarkable strength of character on that front as well. And then, yeah, they had a long and very productive career surveying what ended up being millions of stars that they managed to survey, categorize, and such like. So yeah, a very successful career for an extraordinarily talented scientist who had to battle against limitations pretty much throughout her career because of the inequalities that she faced. But yes, a remarkable woman with remarkable discoveries. You know, to come up with something as groundbreaking as that, to completely change the paradigm around the description of stars at a stage where there are a lot of scientists looking at this sort of thing. You know, it's not like she was in a field where there weren't many people engaged in astronomy and astrophysics and weren't trying to work these things out. I mean, it was a well populated field, and she was the one who made the discovery. So, well worth including on the list of videos of important people.